Welcome to the Science for the Public lecture series. Science for the Public is an organization committed to bringing science information and issues to the general public. Visit our website for our program listings and blog. Good evening. Welcome to Science for the Public's Contemporary Science Issues and Innovations. Tonight we welcome Jeff Deyette from the Union of Concerned Scientists. Jeff Deyette is a senior energy analyst and assistant director of energy research and analysis at the Union of Concerned Scientists in Cambridge, Massachusetts. His areas of expertise include renewable energy and resource and environmental management. He's also co-author of the new book, Cooler, Smarter, Practical Steps for Low Carbon Living, produced by the Union of Concerned Scientists. This evening, Jeff joins us to give some background on climate change and to describe practical choices we individuals can make in transportation, home energy, food, and consumer goods to reduce our carbon footprint while creating a healthier lifestyle. Most of these choices are modest, but they can result in a reduction of carbon emissions by 20% or more. Mr. Deyette also provides some advice from Cooler, Smarter on how to be effective citizens, how to get government to work in the public interest where energy policy is concerned. Cooler, Smarter is based on an in-depth 2-year study by the experts at Union of Concerned Scientists. It's very accessible as a source of information with pointers for both individual and collective action. The book also gives a good analysis of many popular green actions. We're very pleased that Jeff Deyette is able to join us this evening, and thank you, Jeff, and a big welcome.
Thank you very much, Yvonne. Happy to be here.
And I wonder if we could start with the whole issue of climate change, where we still, at least in this country, have a kind of resistance in some quarters. Your book makes very clear that this is unambiguous, that there is a serious issue here. It's not natural. It's not a natural cycle. Could you give us a little background on that?
Sure, right. Well, Cooler, Smarter is really about what the most effective actions that we as individuals can do to reduce the impacts of global warming and reduce our own emissions. But it is important, I think, for people and readers and listeners to understand a little bit about the science of climate change. And we do address that in the book and right up front. And we talk about the fact that the science background or of climate change is not just, the science supporting climate change is not just persuasive, it's the scientific equivalent of a slam dunk, if you will.
Yes.
We know exactly that the Earth is warming, and we know that human activity is causing that warming. And if you'd like, I can just walk through a couple of very simple steps to demonstrate that. So scientists have been collecting data on global average surface temperature for about 150 years now, and we can see that that the temperature of the Earth is rising. The past 15 out of the last 16 years have been the warmest years on record, and I think more and more people are starting to see signs of and feel the climate changing over the years. And in addition to knowing that surface temperatures are rising in the Earth, we also know that carbon dioxide levels are increasing. And scientists have known for a century, have sort of irrefutably proven the greenhouse effect, which is essentially that carbon dioxide serves as a blanket, if you will, that heats, it sort of traps heat around the Earth and keeps it here. It's why we can live on this planet, but too much carbon dioxide in the atmosphere will increase temperatures. And we can show that scientists have been measuring carbon dioxide levels in the atmosphere for about 60 years now, about 50 years. They started at Mauna Loa in Hawaii. It's called the Keeling curve, as you can see on the screen, and it's demonstrating that carbon dioxide levels have increased from roughly 315 parts per million in 1960 all the way up to approaching 400 parts per million, 390 parts per million today. These are levels of concentrations of carbon dioxide in the atmosphere that we haven't seen in 800,000 years. So we've been tracking it for about 50 years, but we actually scientists have been able to unearth ice cores deep in the Arctic, which help tell the sort of story of the atmospheric concentrations of carbon dioxide going back centuries and centuries. And so we know today that the levels in the atmosphere are far higher than we've ever seen on this planet. So that's some of the evidence of why we know climate change is happening. How we know specifically that humans are contributing to climate change is also one of the wonders of science and chemistry, if you will. So carbon molecules have fingerprints, if you will, and we can tell that a carbon molecule that was produced from burning fossil fuels like coal or oil actually has a different fingerprint than a carbon molecule that's just produced or that's elsewhere in the atmosphere. The nucleus of a carbon molecule produced from fossil fuels, from burning fossil fuels, actually has fewer neutrons in it. And so we can tell that actually those types of carbon molecules have been increasing in the atmosphere in the last half century. So that's one way that we know that human activity is causing this. Another way is just by looking at how the Earth's atmosphere is heating up. There's some confusion that's put out there by folks that it might be other natural causes leading to our warming climate, such as solar flares from the sun, or past Earth volcanoes, things like that. So, but we know that that the Earth, if that were the case, the Earth would be warming from the troposphere, the upper layers of the atmosphere, down. The stratosphere, the upper areas of the atmosphere, down through the troposphere, our lower areas. But what's happening is the Earth is actually warming in reverse. The troposphere is warming up first, which is a dead giveaway that carbon dioxide that we're emitting is warming up the lower layers of the atmosphere first and then going upwards. So just a little bit of information about why we are so certain, scientists are very certain that climate change is underway and that humans' activity is causing it.
I just want to compliment you authors of the book in that regard, because I read a lot of stuff. This is a non-technical but very succinct approach to this information, but it leaves absolutely no doubt. So in a short space, you really dispense with all other kind of distractions in this regard, and it's much appreciated. I think your readers will be very happy. In addition, you give a very good breakdown in the book about this the fossil fuel emissions, where it's coming from. Could you give us any background on this, an overview about the sources of these emissions?
Sure. So the leading causes of human driven carbon dioxide or heat or global warming gases being emitted into the atmosphere come from a couple of different sources. Burning fossil fuels primarily. The number one source is burning oil for transportation. So in how we get around, both as individuals, but in commercial and industrial transportation. So rail, air, automobiles all contribute to climate change, so the burning of oil. And then the burning of fossil fuels for electric power generation. And in the United States, primarily that is coal. Coal is the single greatest, coal power plants in the United States are the single greatest source of carbon dioxide that we have today. And in addition to those sources, we also use fossil fuels to heat and cool our homes as well. So it's primarily fossil fuel burning that's causing climate change, though that's not the only cause. Also, the burning of forests and trees across
Colorado,
globally, and in tropical forests particularly, are another leading cause of climate change.
Right, and that you discuss how transportation and large-scale kinds of contributions that we individuals cannot control. Is our contribution to the footprint very significant? We're very willing to do our share, but we have this other difficulty of who's making the big contributions. So you've mentioned, for example, the power.
Sure. So our industries, businesses, so the commercial as well as residential, so the decisions that we make in our everyday lives all contribute significantly to global warming emissions. And so the book is primarily about sort of the individual impact.
I understand, right. But it also points out that, you know, a very large proportion is this other factor, like you say, large-scale transport and all like energy production and so on. And so you give some attention to that as well, which is really important because in many cases, I remember like with the ozone, everybody's got to stop using spray cans, but that's not the primary source. And so this is, sort of redirects our attention very often to what we should do individually, and we will take that up, and that's certainly significant. But I want to point out to people as well that the book does take up the other concerns of where large-scale contributions come from to the CO2 issue. Well, let's go to what individuals can do. This is really enlightening.
Maybe I could just talk a little bit about sort of what the average American's contribution is to global warming. Yes. It's a little bit scary, but we're hoping not to scare people into inaction, right? We want to motivate them and empower them. So what I brought up on the screen here is, the research that we did to find is, we wanted to sort of start by saying, what is the average American's impact? How much emissions are we putting into the atmosphere each and every year, right? Because the idea is for us to really zero in on those actions and those areas where we can make the biggest difference, and to sort of sweat the areas that matter most in terms of reducing our emissions. So when we crunched the numbers, we found that on average each American is responsible for putting 21 tons of carbon dioxide into the atmosphere each and every year. It's about 115 pounds per day.
Isn't
per
that
person.
Amazing? Yeah.
It's a significant number. It's one that's kind of hard to wrap your mind around. We talk a lot about equivalencies in our book, and if you were to put that into perspective, it would be the equivalent of taking an average car and driving it around the world at the equator. So it's around 25,000 miles of driving. And it's also, to put it into perspective, in terms of how much emissions each American emits compared to other parts of the world. So we emit 4 times more than the global average per capita, and we emit more than twice, upwards of 3 times as much as some of our countries that have similar standards of living as we do, like France and Japan, for example. So it's a big number, but the positive thing is that there's a lot of solutions that we can do to reduce this. Our goal is not to guilt readers or our Americans into feeling bad about their current consumer habits. The goal of the book is to inform and empower people to make the smart decisions that will help them find the most effective ways to reduce those emissions. And we challenge readers actually to reduce their emissions 20% this year. And then we give them the tools to do so in the book. So, but what we say is that the most important thing is to actually sweat the areas that matter most, as I said before. And when we broke down that information into where the average American's emissions come from, we found that they came from 4 sort of broad categories. Number one, not surprising, we talked about this a little bit before, so for Americans, the number one source of emissions, you don't have to look in your home, it's actually in your driveway.
Exactly.
It's your car and how you get
Cars.
around. Cars, multiple cars,
Yes.
and how you get around
Yes.
from day to day. So that's the most significant source of individual emissions. Second is the energy that you use in your home, both for heating and cooling, accounts for about 17%, and then home appliances and electronics, so the electricity that we need for that account for about 15%. So when you combine the two up, it's about a third of our energy comes in home energy use. The third category is our diets, the food that we purchase and eat each and every day. About 14% of our emissions come from our diets. And then the last category is sort of a catch-all category. It's the stuff that we buy, the non-food items like lamps, clothing, any kinds of electronics, things like that
Yes.
we are out buying each and every day. That accounts for about 10% of that 26%. The rest of that, actually, of the stuff we buy category are what we call relatively fixed emissions associated with going to the doctor or to the bank, things that we as individuals have less control over in terms of influencing or reducing our emissions. So that's kind of how we broke down those categories. And if you'd like, we can kind of go.
Yes, could we drill down? Because some of those are sort of familiar and some of those are not so familiar. But as you like, how you want to drill down.
Well, we'll start with transportation,
Yes,
because that's the largest. That's the largest source. And the number one piece of advice that we give readers is if you drive, if you have a car, the number one thing you can do to reduce your emissions is to upgrade your vehicle to one that gets better fuel economy. And we really can't emphasize how big of a difference that can make. For example, if you drive a car that gets 20 miles per gallon, which is right around roughly what the national average fuel economy is of our current car fleet, and you upgraded to a car that gets 40 miles per gallon, and 40 is the new 30 in terms of fuel economy nowadays. There are much more cars available now that get 40 miles per gallon. If you made that switch and drove exactly the same, you could actually reduce your emissions, average emissions, by 3.5 tons
That's
per
quite a
year.
substantial amount.
Right. So right there, you're almost at a 20% reduction just from that one measure
And that's
alone.
not changing your driving habit.
No.
That's just changing this.
Changing the efficiency
Exactly.
that the vehicle that you use actually gets you around. And so that not only, what we do in Cooler Smarter is not only talk about actions that you can take that will be effective in reducing your emissions, we also point out how some of these can be really smart in terms of keeping money in your wallet.
Yes.
And talk about, and this decision of upgrading your fuel economy is a great example of that. So when we crunched the numbers on this, and you looked at the fuel economy, the avoided gasoline purchases that you would make over the lifetime of the car, you would be saving some 4,500 gallons of gasoline. And at today's prices,
that's
around
right.
$4 per gallon, you'd be saving upwards of $18,000 in avoided fuel costs just from making that switch from 20 miles per gallon to 40 miles per gallon. So it's a really significant action that you can take. We recognize that not every person is in the market to buy a car this year, so it may not be the decision that the action that they decide to take this year. But most Americans will buy a car in the next 3 to 5 years, and when they do, making fuel economy a high priority in that decision is going to go a long way in terms of reducing their emissions.
So they win in that case.
Correct, yeah.
Absolutely, and we win collectively in that case. Okay, what's another one?
So, well, just another one just on the car side for one more moment. We also advocate folks to drive smarter. And so thinking about ways to drive less, essentially, whether it's carpooling or using public transportation or riding your bike or walking to work, if that's an option for you. Looking for ways to do that maybe one day a week. But also, what I mean by driving smarter is avoiding stressed out driving, which jackrabbit starts, constant accelerating, rapid acceleration, driving 65 instead of 75 on the highway, keeping your car well tuned, properly tuned up, and keeping the air pressure in your tires at their recommended levels. All these little things in terms of finding ways to drive smarter will actually save as much as 7% of your transportation-related emissions, or avoid that 7% of those emissions, and save you as much as $500 per year in avoided gasoline.
Yes.
So again, another money saver.
Right, and also makes you feel good.
Sure.
Right.
Sure. Moving on to the energy that we use in our home, that two things that we advocate for with respect to heating and cooling. It's a little bit different than in the transportation, where the number one thing we recommend you do is go out and buy a more fuel economic car. In the home, it doesn't necessarily make sense to go out right away and switch out your furnace or your central air system. And that's because what we found is that most American homes are so leaky in terms of letting air out, escape, that it's actually far more effective strategy to focus on that as a carbon emissions reduction tactic first, before you take other measures. And just to give you an example of this, I can bring up an image that shows where air escapes from our homes.
Oh dear.
So whether it's the fireplace or the windows and ceilings, attics, electrical outlets, ducts, doors. There's lots of places where air can escape from our homes. And when you add it all up, it's the equivalent, or it's roughly as much as 25% of the energy that we use to heat our homes in the wintertime or cool our homes in the summertime, escaping from our homes. It's the equivalent, actually, of leaving a window in your home open all year round. That's how much air escapes. So anything that you can do to seal up those gaps and ducts and ceilings and doors.
It's scary looking, isn't it?
Will make a really significant, discernible difference in your carbon emissions, and it'll actually pay for itself very quickly in energy savings alone. So that's one area that we really tell people to focus on. And you can do a couple of things. One, you can actually you can go out and get a professional energy audit. We certainly recommend that, either from your local utility or the state energy office here in Massachusetts. Offers free energy audits. Many states actually have that option now. And so they'll come in and actually tell you all the places where your air is leaking. But you can actually go around and sort of use just sort of the hand test or other sort of simple methods to discover where some of the biggest problems are. And simply with $100 worth of insulation and caulking, you can make a real big difference just in an afternoon of working on that. The other area in our homes that we recommend folks really go out and do right away, because it's one of the cheapest and most effective things to do, is to go out and purchase a programmable thermostat.
Yes.
Millions of homes already have them, but and more than half of American homes don't have them today. And if you don't, we recommend you go out and get one right away. And if you do, we recommend that you check and make sure that you're actually using it properly. And the reason why is a programmable thermostat can actually reduce your heating and cooling costs by as much as 15% over the course of a year, just in being smart about when we use our heating and cooling. So making sure you're having a programmable thermostat set to turn down at night when we're sleeping, or during the day when we know we're going to be away at work, for example, can make a real big difference. $20 investment in a programmable thermostat could save you as much as $180 per year in reduced energy costs, and as I say, make a big difference in reducing your carbon emissions.
So far, all the money that has been saved with the transportation issue and now the home energy part, primarily through heating and stuff, adds up. It's already substantial. There are other areas, as you mentioned the electricity thing at home. I wanted to make sure, because that was very cleverly done in the book as well, that we waste a lot of electricity, not just by lights, but by other seepages that...
Yeah, so lighting certainly is, it's no secret. Actually, next to heating and cooling, lighting uses the most amount of energy in our homes. Changing out those incandescent light bulbs, they're 19th century technology. Let's get them all out of there and replace them with modern day LED lighting and compact fluorescent lights. There are just so many options on the market nowadays to fit anybody's lighting needs, and the costs have come down significantly on these technologies, and they save a tremendous amount of energy. They use as much as 75 to 85% less electricity than a standard incandescent light bulb. And it's interesting, one of the things that we found in our research is that most Americans, when they when polled, when asked about what they find is would be the most effective conservation strategy or energy saving strategy, they talk about conservation, turning out the lights. Rather than switching out light bulbs. They're actually 5 times more likely to do that than to switch out light bulbs. And we point out in the book just how while we recognize the importance of conservation and being mindful about turning out the lights, just how much more energy you can save by switching out those light bulbs.
Right.
You'd have to turn your lights out. If you left your incandescent lights off and just focused on that conservation strategy, you'd have to keep those lights off 3 out of every 4 days of the year in order to get the same amount of emission savings as just switching them out. So we recommend getting them out of there right away.
Yeah.
A couple of other things just on the electricity side, in terms of major appliances.
Yes.
One of the interesting things that we found in our research is that the old adage, if it ain't broke, don't fix it, doesn't apply, especially when it comes to refrigerators. Today's refrigerators are up to 70% more energy efficient than those that were manufactured even just 10 years ago.
Wow.
Since 2003, actually, since the most recent federal standards have been put in place. So what we recommend is, and the reason why we recommend actually, if you do have an older refrigerator, to actually replace it before it breaks down. Most people would want to wait until it breaks down. It's actually better from a carbon perspective to replace it sooner rather than later. And the reason why is because when we crunched the numbers and looked at the carbon emissions associated with a refrigerator, those emissions embedded in the manufacturing and transportation of the refrigerator to your door, to the store and then to your door step, are far smaller in comparison to the emissions associated with the power that you use to run that refrigerator 24 hours a day, 7 days a week, for year in and year out. So it's actually way more effective to replace it with a more efficient one sooner rather than later.
It's a really good point, those things, because once you start realizing this and become conscious of it, then it creates much more willingness for people. They feel like they can control that. Am I mistaken here? Did you also mention that our habit of, well, we think that we've turned things off, but in fact, as things are plugged in, there is some seepage here of electricity, and I'm not sure that we're very aware of it. Is that a significant thing? Or?
It's a growing energy hog, if you will. It used to be smaller, but today off doesn't mean off with most of our modern electronics, right? The average American home has some 40 gadgets, electronics, or appliances plugged in all the time. And when we think they're not actually off, whether it's our toaster oven or our television or our printer or computer, doesn't necessarily mean that it's off. In some cases, it can be drawing substantial amount of power. For example, a television, today's modern televisions draw as much power in just 20 hours of being turned off as they do in 4 hours of being turned on. So they're still draining quite a bit of power.
Exactly.
And what we recommend there is, some of these things you can control. You can just simply unplug when you're not using them. But another really smart way of doing this is to focus in a couple of areas, what we call nesting areas, where you find all kinds of cords behind your television, typically, and behind your computer in your office. And we have smart power strips now, where you can actually plug in a computer, and you have your printer and router and other items, monitor, all plugged in side by side with it. But those things are actually off completely when your computer shuts off. So you actually aren't leaving your printer on.
You don't have to go 1, 2, 3, all of the equipment.
And it shuts it off completely.
Right.
It cuts the power to those while it keeps may keep the computer on standby if it needs to be, for example. So going out and purchasing these smart power strips are really an effective way to kind of reduce your what we call vampire loads.
Yes, right.
And just frankly, one of the other things that we found that really makes a big difference in your home is just having a better understanding and being more aware of the energy that you're consuming. And one of the ways to do that is to purchase or borrow from the library what's called a kilowatt meter. And it's just a simple gadget that you plug into an outlet, and then you plug in your television or your lamp or your appliance, and it'll tell you exactly how much power it is drawing at any one time and over the course of a day or a month. So you can really identify those gadgets or pieces of technology that we have that are really the biggest sources of energy in our house, and then decide whether or not that you need them plugged in all the time.
Right. I think you pointed out in the book too that it really wakes people up. They're very willing in that case, that Americans in fact don't mean to hog all the electricity and everything else, but that once awakened, once made aware of this and given the ability to monitor these things themselves, then they're very willing to make changes as well and adapt in that way.
That's right.
How about food?
Sure. Our diets, actually, as I said before, account for about 14% of our average annual emissions. And the number one piece of advice that we give when it comes to food is to eat less meat, especially red meat like beef. And the reason why is because pound for pound, red meat, beef, actually produces far more global warming emissions than any other food in our diets. When we crunch the numbers on this, when you count the emissions associated with the agriculture used to feed the cattle, the emissions that the cow puts out each and every day in its life, methane emissions associated with that, and then when you count the emissions for processing that cow into burgers and steaks and whatnot, it all adds up to some 18 times the number of emissions that you would get from an equivalent pound of pasta, for example. So there's far more emissions embedded in beef than there are in fruits and vegetables. And what we say in the book, we're certainly not advocating that everybody go out and become a vegetarian or a vegan, for that matter. There are actually compelling reasons to have some meat in our diets. But just simply cutting back on our meat consumption can really make a significant difference in our emissions. Just as we say in the book, just moving your meat from the center of your plate to the side of your plate in your very next meal can make a big difference. If a family of 4 actually cuts their meat intake in half, they could reduce their emissions by some 3 tons of carbon dioxide over the course of a year. So it can make a big difference when you try to eat less meat. I personally find it difficult to maybe cut my meat intake in half, but one of the things that we also recommend doing is maybe just trying to do 1 day a week, have a meatless Monday.
It seems like a lot of people are doing that.
Trying to do that really is a good place to start for some folks. And we've got a lot of, we as Americans actually eat quite a bit of meat. When we looked into this, the average American actually consumes some 270 pounds of meat every year.
A lot of cows.
Right. That's 4 times the global average. So there's plenty of room for us to increase you know, our diets in terms of fruits, vegetables, and whole grains.
Well, that's another thing, is that our portions are huge compared to those of other cultures. So you know this, you have this quarter pounder. Someone was telling me recently the average hamburger is now a quarter pounder, and you really don't need all of that. So it would be good for the waistline as well, and good for health,
Right.
perhaps. Just on that, for the beef, very quickly, is that grass-fed beef as well as our corn-fed beef is just enormously wasteful, and corn to feed them is also enormously wasteful, but there are also health effects from that. If you were doing grass-fed beef and a little less, would that make a difference, or is it just beef?
It will make some difference if you're using grass-fed with, you know, organic farming practices. Certainly will make some difference in lowering those emissions, but there's a lot of emissions embedded just in you know, in other areas of the production of beef, that it's still something that we should be looking for ways to reduce to the extent possible.
It's one of the interesting things in the book is that you think, oh, if I just do local or grass-fed or something or other, but in fact, when you really look at that, you have to be a little more careful, and so the book gives very good information on this. Yeah,
that was one of the surprising things we actually found.
You didn't expect it.
That we didn't really expect, but we found when we did the analysis, which has to do with you know, one of the things that you don't need to sweat so much when it comes to our diets and reducing emissions, and that's how far our food has traveled, food miles, if you will. So when you're in the grocery store, you know, and you're stressing about whether the food has traveled 100 miles or 1,000 miles, you really don't have to worry about that so much. What's way more important in terms of carbon emissions or heat trapping emissions is how that food was produced. And I have a graphic here just to sort of illustrate that that I'll bring up, which shows essentially the emissions associated with getting our food from the farm to the factory and then onto the store. And that's in blue on these bar charts for the various types of food groups. The red in the chart actually is the inputs that go into the farm and the factory, the processing of the food, if you will. So as you can see, in each of the categories, whether it's red meats or fish or eggs or even fruits and vegetables, there are far more emissions associated with the production of the food than getting it from point A to point B. And we do stress in the book, and UCS as an organization is very supportive of locally sourced foods, using community-supported agricultural programs. There are a lot of reasons to be supportive of those of locally sourced food and knowing where our food comes from. It just so happens that carbon emissions doesn't happen to be you know, utmost in importance from that perspective.
Right, I understand, but that's a very good graphic.
Sure, yeah. Just another quick thing in terms of ways to reduce our emissions in our diets, and you touched on this a little bit, but it has to do with food waste and packaging of food. So to the extent that you actually do purchase and eat more fruits and vegetables and whole grains, you're actually going to be reducing packaging, which will make a big difference in reducing your food-related emissions. But also just being more mindful about how much food that we prepare and purchase at any given one time will make a significant difference as well.
Right. Just a quick point about this packaging. Again, that's another American sort of over-the-top approach to things, that you can barely get this stuff out of whatever it is delivered, and because of this excess packaging, a lot of plastic, a lot of other things that maybe don't recycle well, and so on. So that's quite something. Let me think now, what else was there in there? So the food and the energy at home and so on.
So the last category that we haven't touched on yet would be the stuff that we buy, right? Those non-food items that we purchase. And here, I mean, it's not rocket science, the actions and the recommendations. the thing that, well, as important as it is to try to go out and look for the most environmentally benign products that we can find, and as an example in the book, we talk about how important organically grown cotton for clothing is compared to cotton that's not produced organically in terms of the emissions that are associated with that. That is one area.
Which is a surprise.
One area where you can actually make a big difference
Yeah.
in the stuff you buy category. So as important as that is, the thing that's going to make the most discernible difference in reducing your emissions is just to buy less stuff.
Uh-oh, I hear you have a shopping society. That's
to sort of just really think about whether or not you need, an item or not before you purchase it. The one exception to that rule that we talk about in the book, and I touched on this a little bit, is when it comes to things that use energy in your home. So if it's your refrigerator, or if it's your car or your home computer, because there are so many more emissions associated with the energy consumed by those products as opposed to the energy embedded in the manufacturing and transport of them. It's actually better if you can upgrade that product and you're still going to use it with one that is more energy efficient. It's actually better to do that and go out and purchase it rather than to keep the one that you have.
Right, but the overall point was you could scale back and be much more comfortable. In fact, you don't need all this stuff. Now, one more thing here about in terms of the saving energy, I forgot to mention it before, was that in an urban culture, a lot of people are renting in buildings, and so we have one thing, offices or shops or whatever, that's using a lot of energy, but if you are renting an apartment, then is there anything that you can do to control the energy a little better?
Yeah, sure. So, we tried to write Cooler Smarter in a way that was accessible to kind of meet almost any lifestyle.
Yes.
So whether you do live in an apartment in a big city, or whether you live in in the suburbs with a long commute to work and live in an old house with a big family, we provide a menu of actions, right?
Yeah.
There's no one size fits all
Obviously.
or silver bullet solution, right?
Yeah.
And so when it comes to renters, if you are in a big city, typically your emissions profile may be a little different than the average Americans. You may have fewer emissions because you probably live in a smaller space in your heating and cooling costs and things like that. So, but you can in your home even if you're renting, take some steps, right? You're certainly free to change out your light bulbs.
Yes, this is true.
And invest in that. Actually switching out the programmable thermostat is something that most anybody can do and read the instructions.
That's a good point, because most people don't think that you can go out and get one.
I mean, it's probably a smart idea to talk to your landlord about that, but I mean, these are small things. You might be more difficult to get them to add more insulation into the walls, into the attics, but there are a lot of areas that you can really make a difference. So another simple thing that you can do, whether you rent or buy your home, is in doing your laundry. So
yes,
we found that actually washing your clothes in cold water actually uses 5 times less energy than washing a load with warm water. So the energy used to heat that water up. So simple things like that.
Clean.
And they're just as clean with today's
Yes,
modern detergents.
Exactly, with the detergents that are available. Is another very good point.
Right. So there are lots of ways, if you're a renter, that you can focus on reducing your emissions just in your home. But if you also live in a big city, then you're more likely to have access to public transportation.
Which is
you're more
a big
likely
savings.
to live closer to your grocery store or your place of work. And so you can take advantage of ways to reduce your transportation related emissions.
Exactly.
And then anybody, no matter where you live, can really make decisions about reducing emissions in your diet and the stuff that we buy.
Exactly. So they really do have a lot of options, and that is pointed out very well. Okay. Now, in your book, you also do a very good job of saying what we can do as citizens, because we need to make government pay attention to us, and it's very doable. In fact, it's very upbeat in that regard. Could you tell us about that?
Sure. So in the book, as I said earlier, we are challenging readers to reduce their emissions 20% this year, but that's only part of the challenge that we make in the book. We actually are also asking them to not keep their smart decisions to themselves,
Exactly.
if you will, right? Go out and be what we call low carbon leaders. And that is going out and talking to friends, families, coworker, members of their community, and elected officials, and corporations and companies that they purchase from, to also hear the call for reducing carbon emissions. And so, and we spend about a third of the book providing readers with information about and suggestions about the most effective ways to do that. And so
we've taken care of our everyday needs and so on, and if there is anything else you'd like to bring up, I will, and otherwise I'd like to find out how you got into this whole business.
Sure. Well, just a couple quick things.
Yes.
So one of the other things that we sort of provide in the book is we tell readers about the things that maybe they don't need to sweat so much.
Okay.
Right? So one area, just one example. I talked a little bit about the lighting and the conservation versus the switching out your light bulb sweat strategy. But another area that's very topical nowadays is this whole notion of e-readers versus books, paperback
yes,
books.
Right.
And so when we crunch the numbers on this, I think some people maybe feel a little guilty about their e-readers, or actually have heard maybe buying books produces more carbon emissions. In fact, when we crunch the numbers, unless you are an avid reader, and by avid reader I mean 30 or 40 books a year that you go out and buy new, you're likely to have e-readers may be slightly better over time, but it's a net wash essentially in terms of carbon emissions. So if you like reading the old-fashioned way with paperback books, or if you're really into e-readers, from a carbon perspective, it doesn't really make a difference. So that's just an example of one of the kinds of things that we talk about in the book, not to sweat.
Yeah.
The other thing that I just wanted to point out is in the book and sort of in our messaging that we talk about with this is just how big of a difference individual actions can make when they're scaled up, right? And so we have a website called coolersmarter.org,
yes,
where folks can go and kind of learn a little bit more about this. What if you took this one action and what the carbon emission savings would be? If you went out and got 20 people to take that same actions, what kind of savings would that increase to? 20,000 people, 20 million people taking the same action. When you start to add it up, and it's the scale of the emissions reductions becomes quite significant. Okay. And what we found was if every American were to go out and actually reduce their carbon emissions 20% this year, it would be equivalent to shutting down 200 out of the 600 dirty coal plants that we use in this country.
Well, that's very significant.
So it's one third of the coal plants in this country we could shut down.
Just by being careful.
Just by taking some really easy and smart actions in our daily lives.
Okay. Now, can I shift here in our last few minutes? I'd like to find out how you got into this. Seems like it would be a most wonderful job. And so you mentioned, like a major that I didn't even know existed. So could you tell us, you're a local guy, right? You came from the program right here at BU?
Sure, at BU, yeah. Well, I got started in being interested in environmental issues, back in high school. I have an older brother who was in the Peace Corps working on environmental issues in South America, Central America. And just when I started college, got into some environmental classes, very much love of outdoors, and grew up near the Adirondacks in New York. And so kind of took environmental science and majored in environmental science. When I went to grad school, I focused on energy resource and management, and it became so clear to me how energy resources and our energy consumption really is the linchpin, if you will, to so many environmental issues and so many opportunities for us to make improvements, not just on climate change and global warming, but all kinds of air and water pollution, issues. And so that's kind of where I got started by taking a course, entering into a program here at Boston University on energy and resource management.
And that just led the way, right?
Sort of led the way into a job with the Union of Concerned Scientists,
Yes.
and we're a national science-based nonprofit organization.
Yes.
We've
With
been around.
a very wide spectrum of concerns, actually.
Yeah, we've been working. It's an organization that's been around for 42
Yes.
years, and we were started by here in Massachusetts, in Cambridge, at MIT, by physicists and students who were concerned about nuclear weapons proliferation.
But you've really diversified.
And have since diversified out to a
Yes.
whole host of global environmental issues.
Yes, I think it sounds like a wonderful field to be in, and evidently it's really expanding. You mentioned, you have a concentration here already, and we start out thinking just environmental, and not only that, but that it was sort of gloom and doom for a long time. This has just turned things around. It's that people can be active, they can take charge, you can do something about this, and so the being in this field, it's maybe an excellent time for that.
Yeah,
what's your
I think
recommendation
so.
for?
I certainly would. I think it's it can be frustrating, no doubt,
Sure.
trying to make progress at the federal level with policies.
Yes.
But there is I'm encouraged by just the scale and speed with which solutions can take hold and really multiply when we pull the right levers.
Right.
And it takes a long time to sometimes to get to pull those levers, but when we do, we really see the pace of change so quickly, and it makes such a big difference.
Yes, that's by the way, it's one of the things that you mentioned, but I'm aware that you worked on this as well, that you said that turning to alternative energies, it's not, we keep being told, oh no, this is far, far away, but you say, no, that's not true. We can do an awful lot right now with the technologies. Is that the case?
Yeah, that's absolutely true. I mean, what Cooler Smarter is about, sort of bottom up, people taking advantage of technologies, but we actually have large-scale, utility-scale solutions to kind of replace our fossil fuel-sourced power generation and move to cleaner, more sustainable, renewable energy technologies like wind, solar,
yes, right.
and
wave, maybe.
And we've gotten the technology advancements on the transportation side to really reduce emissions, and we're seeing that both from electric powered vehicles, hybrid vehicles getting greater fuel economy, but also with potential new sources of power. Using biofuels and others to power our vehicles. So so there's a lot of technologies happening, and it's really moving very quickly. Solar energy, for example, has actually increased 100-fold in the last decade.
And getting much more efficient.
Much more efficient, much more cheaper, for individuals to install.
Yes,
so we're seeing these technologies
and in view
grow.
of the fact that a lot of these areas promote jobs as well, there will be just all kinds of jobs spilling out of these energy things that it just looks very hopeful. But I'd like to say that in closing, the book is very hopeful. It's very upbeat, and in focusing on, especially on what individuals can do to take control of the thing, because we often feel like it's out of our hands, and this just turns you around completely. So we're very appreciative of this effort on your part.
Thank you very much.
I thank you very much for joining us, and if people would like to ask questions and talk to you, that will just be fine, okay?
Great.
Thank you very much.
Thank you, Lynn.
Okay.
Yeah, actually, that's a good point.
The planes are...
So the reason why I didn't talk necessarily about air travel is because for the average American, our transportation emissions are roughly 92% of our transportation emissions are associated with cars. And so for most people, air travel is not a significant source of air emissions. That's not the case for every American, certainly. And for those people who do fly a lot for vacations or for work, your emissions will be significantly higher, and your transportation-related emissions will be significantly higher associated with air travel. And so we do talk about in the book different ways that you can reduce your emissions through air travel. A couple of the, one I think people would be happy about. One is actually taking direct flights is an effective way to reduce your emissions. So not doing that layover. If you can spend an extra, $100 or so on that, that's a smart tactic. And one that you might not be too excited about, and that's not flying first class. Flying in back in coach.
Fly first
exactly.
class.
When you're crunched
not
up
an option.
like a sardine in back in coach, you can feel a little bit better about that, because your carbon emissions are far less than those folks who are sitting up in first class. Just because the number of people that we put on an airplane actually will significantly reduce the per person emissions, and so being on a full plane is a pretty effective way to
right.
On that subject, have you looked at per passenger mile though? Are airplanes much worse? Because like if you were to get in your car with just a lot of fuel use.
It is, actually, and it's funny you mentioned that. I have a slide here that we can bring up,
sure,
perhaps,
go ahead.
which talks about per passenger
per
passenger miles. And you're right. I think that the number one message here is the more people you can load into a vehicle and take them, whether it's a car or a train or a bus or a plane, it will have a less of an impact in terms of CO2 emissions per passenger. Driving a typical SUV alone is the single worst thing that you can do in terms of
in
per
case
passenger
you haven't noticed the traffic in Boston.
Emissions, as you can see here, even adding one passenger to that SUV really makes a difference, but it's still one of the worst things that you can do. But interestingly, taking a regional jet and flying it 250 miles is fewer emissions than if you actually got in a car by yourself, not an SUV, but just a passenger car, and drove that same distance.
And that's what your point was.
So that is one of the things that we do point out in the book, that how you get around. The best thing that you can do is look for opportunities to take train. Or load people in your car if you're going to go. Don't go by yourself. Find some friends and carpool. Take them on that trip.
Pick people up as we go along.
Right.
You also look at the numbers for how long it takes to pay back a year and there.
Yeah. We don't go into that detail for every action that we recommend, but we do for some of them, and we provide resources. As Yvonne mentioned, there's a really good sort of resource section in the back of the book with some great websites where you can do that. So, for example, with the refrigerator that we were talking about earlier, the Department of Energy has an Energy Star program. Their EnergyStar.gov website has a function there where you can plug in the model of your refrigerator. You can learn how much energy it uses, and then you can see just how quickly a new one will pay for itself. And in some cases, we found that it was as little as 3 years for a payback time for a brand new refrigerator. And as I mentioned with the car, going from 20 to 40 miles per gallon, $18,000 over the lifetime of a car.
What is the lifetime of
15 years is what we average, and so that's 18. That's almost enough money to go out and buy a new car. But if you just even don't plan to own that car for 15 years, you're saving still roughly $100 per month in avoided fuel costs. So that's enough to maybe spend a little bit more on a car that gets more fuel economy. It may be a little bit more expensive, but you can afford that higher loan payment because you're paying less for your fuel.
Yeah. Can you see him back there?
Oh, yes, sir. Yeah.
So most people have like cell phones and like computers. So if, for example, I were to I take my cell phone out of its charger each morning, but the charger stays plugged in. Is it still drawing energy?
Yeah, yes.
Should I like unplug it every day?
Well, you know, it's this is why I recommend going out and getting a kilowatt meter and trying to sort of really figure out which of those things that stay plugged in are drawing the most amount of power. Your charger for your smartphone actually draws very little power when it's not plugged into your smartphone, and so. From a good habit standpoint, it's probably better to unplug it, but you know, it's one of those things that's not going to make a big difference. It's far more effective to look at, say, your printer.
Yeah,
surprisingly, your
surprising.
printer uses as much as $140 a year